All right, we left off last time with me asking you to try this first example, try to write out an explanation. And I really want to encourage you, before I show how these three examples are done, that you try each of these three examples yourself and see what you can get to before I show how this works, because this is not this process is not a spectator sport where you can just watch it be done and know how to do it. You need to take part in that explanation process yourself and try and wrestle with it for a bit, and then be able to see, oh, here's the bit I'm missing. Here's the missing link that was stopping me up. Or maybe, oh, I had this and I had the right idea, but I needed to say a little bit more in this spot. So, with that being said, proving that angles 1 and 3 are congruent. Now, the way that we're going to do this, again, if you're stuck, the advice I gave last time was try it with numbers. And so let's say that we know that this is 80 degrees, that angle 1 is 80 degrees. The goal is to get angle 3 to also be 80 degrees without just saying, hey, they're vertical angles. What we are proving is that they are vertical angles, is that those vertical angles have to be congruent. Luckily, even though we wouldn't be able to get to angle 3, we do know, based on angle 1, we do know what angle 2 would have to be. And that's because angle 1 and angle 2 are a linear pair. So that angle would be 100 degrees. And there's nothing special here about 80 and 100. I just picked them because they were easy numbers to add together. There's nothing special about 80 and 100 here. I can use any numbers here and this same argument will work. And good news, since 2 and 3 are also a linear pair, since that's 100, this is going to be 80. And there we have those two angles being the same. So that's the basic argument that we're going to use. And I'm going to show you a couple different ways that this argument can be structured. So the point of me showing you this argument a couple different ways is to say you don't need to have one specific correct answer here. The idea is that it is not you have to have exactly this paragraph and exactly these sentences in this exact order with exactly these words, otherwise it's completely wrong. It is we are working on a skill of being able to explain ourselves. And the main thing that I want you to notice is that each step, every time we make a statement or set up an equation or say that something is congruent or adds to a particular thing, we are having a reason for each of them justifying why that has to be true. Each step has to have a reason to go along with it. So let's look at a couple different ways we can prove this statement. Again, the argument is always going to rely on we have a linear pair linking 1 and 2 and 2 and 3, which will make 1 and 3 congruent. So, first proof of this. In the diagram, angles 1 and 2 are a linear pair, and so are angles 2 and 3. Therefore, so we have those linear pairs, therefore, these pairs of angles must both be supplementary. That's because they are a linear pair. Now that we know we have angle 1 here that adds with angle 2 to be 180. And then we have angle 3 over here that adds with angle 2 to be 180. Well, in order for that to happen, it has to be true that angles 1 and 3 are the same. In order for angle 1 and angle 3 to both add to angle 2 to be 180 degrees, the only way that this can happen is for them to be the same measure. And that is because angle 2's measure must be equal to itself by the reflexive property. So when angle 2 is added to angle 1 over on this side, it's the same as it being added to angle 3 over on this side. So we're saying that angle 2 is equal to itself. And the reflexive property that we talked about last week is what lets us say that. Therefore, angle 1 is congruent to angle 3. So this is more written out as a paragraph structure to explain this process. Now, I'm going to show the same argument, but I'm going to make it in a little bit of a different format. So maybe if this was just a wall of text to you, this format might make more sense. So, same argument, but I'm going to phrase it a little bit differently. Angles 1 and 2 and angles 2 and 3 are both linear pairs. This means that by the linear pair postulate, here's angles 1 and 2 being a linear pair and being supplementary. And then here's angles 2 and 3 being a linear pair and being supplementary. So they both have to add to 180. Therefore, by the transitive property, remember, says that if A equals B and B equals C, then A equals C. In other words, what I'm saying is, if two things are equal to the same thing, they're equal to each other. These things are both equal to 180, therefore, they must be equal to each other. That's what the transitive property lets us say. And if you look at this equation, you'll notice that both sides have measure of angle 2. So I can just subtract the measure of angle 2 from both sides, and I end up with angle 1 and angle 3 being the same measure. Oh, the angles are the same measure? That means they're congruent. That's what congruent means. That's our definition of congruence. And so we wind up at our conclusion that these vertical angles across from each other have to be congruent. So it's the same argument, but just made a little bit differently. Let me show that same argument with a different way of organizing it. So this is way number 3 that we can do it. This is making sure that every statement we have is backed up by a reason. So on the left, we're going to say, here's the thing we can say. And on the right, we're going to say, here's why we can say it. So first 2 steps, linear pair postulate says that a linear pair is supplementary. So angles 1 and 2 have to add to 180, and angles 2 and 3 have to add to 180. That's because they're both linear pairs. This is saying the same thing that I set up here, just in a different way. And notice that I didn't just make these equations out of nowhere. I explained and talked through, here's why I can set up what I can set up. Here's why I can set these equal to each other. Right? Every statement has a reason backing it up. Now, from there, we can get these equal to each other by the transitive property. That's why I put it in purple, because it came from the red and the blue statements mixed together. Now, since angle 2 is on both sides of the equation, it's equal to itself. That's the reflexive property. It says that something's equal to itself. Therefore, I can just subtract angle 2 from both sides and get angle 1 and angle 3 being the same. This way of organizing things is called a 2-column proof. This is the way you'll see a lot of geometry textbooks show this kind of proof. And it has the idea of making sure you organize yourself so that every statement you make has a reason justifying it. So this is that same proof in a 2-column structure. And finally, before we go on, I just wanted to show, here's Euclid's proof. Ancient Greeks in Euclid's The Elements. The diagram is basically the same. And the only real difference in this proof is that instead of saying that they make 180, or making a linear pair, it says they make 2 right angles. And if you think about it, 2 right angles, that would be 2 90-degree angles added together, I get 180. But it's making the same argument. It's laying out, here's the information, here's the diagram, here's where the angles are. Then it says the straight line stands on a straight line, making angles CEA and AED. In other words, these angles are a linear pair, so they add to 180. Then in the next paragraph, these angles are a linear pair. They add to 180. But hold on, that matches with the linear pair we had here. Therefore, we can make these equal to each other. Subtract AED from each. That's taking away angle 2 from both sides. Then the remaining angles must be equal. And we can make a similar argument for the other pairs of angles. Therefore, vertical angles are congruent. And they have a little phrase QED down here. That's basically Latin for we have proved what we set out to prove. So in a lot of math textbooks, you'll find this QED as basically a mic drop to say we did it. So that's the first example. And I'm going to show you a couple proofs of this next example. But I want to kind of start you off on it first. Remember, if you're stuck, try putting in some measurements and see what you can come up with. So here's A to L, and here's S to K. And we are told that they are congruent. So I'm going to put little tick marks there. And what we are setting out to prove, based on this information, we're trying to get A to S and L to K. We're trying to get that pair of sides congruent. And so think about how we can get from A to L. How do I get from A to L to A to S? And how do I get from S to K to L to K? Because that's going to be the key to doing this problem. So pause for a moment and see what you can come up with. See what kind of equations you can make or explanations you can give. And now hopefully what you might have spotted is that to get from each of these segments in red to each of these segments in blue, what we need is this yellow segment, L to S. This is going to be the key. That this segment, when I add it, it creates the segments in blue on both sides. And since L to S is the same on either side, regardless of which way we do it, that will preserve the measurements being the same when we go down here. So again, I'm going to outline and show two different ways that we can explain and come up with this proof. So again, there's a few different ways to show it, but here's the key part. If I'm reading your proof, if someone is looking through your proof, they should see a justification backing up any equation that you set up, any explanation that you give. So if we say something like, hey, these add to 180, or these have to be the same, I know how you got there. I don't need to ask, how'd you get there all of a sudden? Why are you adding them to 180? How do I know I can do that? I have this equation here. How did I set it up? You're explaining why I can set these things up. So that's the thing to kind of check. Read through your explanation. And with every equation that you write, make sure that you are backing it up with an explanation. All right, let's look at this example. So using our given information, again, I'm explaining why we are setting up A to L equal to S to K. I can do that because that's the information I was told. Then I know I'm going to use this common side L to S to get to A to S and to get to L to K. So I'm going to set that up by adding L to S to both sides of the equation. Since it's the same thing, I can add it to both sides of the equation. That is allowed. That is a legal move in mathematics. Add the same thing to both sides of an equation. Then I can say, notice, I saw a lot of people get here, but notice that where I am not at is at A to S. I am not at L to K. So I need to get from here to A to S. I need to get from here on the right side to L to K. How am I going to do that? Segment addition postulate. Segment addition postulate is what says I can take the pieces, add them together, and I get the whole thing. It's what lets me say, oh, wait a second, A to L and L to S, that's A to S. On the right side, S to K and L to S, that's L to K. Those pieces add together to get the whole thing. So I can take, on this left side, I can take and substitute in A to S. On the right side here, I can take and substitute in L to K, which gets me at the conclusion that I wanted to come to. Now, if you prefer the explanation just written out, then we can write it out. Here it is written out. The only difference you'll see here is that it's done in a little bit of a different order. So I'm going to make the argument that's in red first, and then the argument that's in blue. So instead of saying I can add L to S to both sides, and hey, that's A to S and L to K, I'm going to walk through that I can make A to S by these two segments and make L to K by these two segments, and then say, well, wait a second, that was just adding L to S to both sides. So here is that argument. From segment A to L, we can create A to S by adding L to S. Similarly, we can create L to K from S to K by adding on L to S. So that's describing, here's how I can get to A to S, and here's how I can get to L to K. By adding on L to S, and by adding on L to S. And then I'm going to say, well, wait a second. Both times I just added on L to S. And L to S has to be the same on both sides. That's the reflexive property. That's the reflexive property that says I can add the same thing to both sides. Won't change those two things being equal. Therefore, they have to be equal to each other. Again, you can use the way that makes sense to you, but make sure that when you make a new equation, or when you say that these things create this, make sure that you're backing that up with an explanation as to why that works, why you're allowed to do that, where you got that number from. So, try this last one. This time I'm not giving you a conclusion. I'm asking what conclusion we can make. And I'll give you a hint that I'm looking for a specific number that these two angles both have to be. So see if you can figure out what the angle has to be, which I think most of you can come up with. And then, the harder part, explain how you can get there. How do you know that that is the measurement that needs to happen? So I'll pause for a few seconds and let you pause and try it. All right. Hopefully, you were able to reason yourself to the fact that both of those angles would have to be right angles, 90 degrees. And again, I'm going to show a couple different ways we can argue this, that we can explain this. Here it is just written out as a paragraph. Angles ABD and CBD are linear pairs, so they'll be supplementary. In other words, they're going to add to 180. But I need to explain how I get from there to those smaller angles being 90. How do I know that they're both 90? How do I know that they're not some other number? So I'm going to explain, well, I have two of the same number. Since they're congruent, I have two of the same number, and I want them to add together to be 180. So my only choice, if I want that to happen, the only way I can have two measurements be the same and add to 180 is if both are 90. That's the only way that can happen. So now I've explained why they both have to be 90. Therefore, these angles must both be right angles. So that's it explained out in words. Now, if you prefer to explain it by showing an equation, here's the same argument, but shown with an equation. First off, the angles are linear pairs, so they're supplementary. Now, I don't know what angle ABD is. I don't know what angle ABD is. So a great thing to do, if there is a measurement that I don't know, let's use a variable. That's what variables are for, to stand for things that we don't know. So since we don't know ABD, we'll call it X. But, since I know ABD is X, then DBC, which is equal to it, has to also be X. They have to be the same. That's what congruent means, is that they're measured the same. So if one is X, then the other is X. Which, from that equation up at the top, if they're both X, then I have the equation X plus X equals 180. And since I have X plus X equals 180, I can just take that, combine like terms, divide, solve, and look at that, they're both 90. Since they're both X, I can say they're both equal, and they're equal to 90. So they have to be right angles. Now, one more way I'm going to show to explain this, just so that you see a couple different ways I can explain it. I like this one because it's completely different. These ones relied on the fact that we have a linear pair and use them adding to 180 to talk about that. However, I can go a completely different approach. I can say, well, hang on a second. Here are two angles. Here's an angle that got split into two pieces that are the same. And if an angle was split into two pieces that are the same, well, we have a name for that. It's a bisector. It has to be an angle bisector. So that means angle ABC was bisected, was split into two equal pieces. It was split in half. So it was a bisector means that ABC was split in half. Since ABC is a straight line, we know its measurement. We know that its measurement is 180 degrees. That means if we are splitting that 180 degrees in half, that leaves each of them to be 90. And we have our measurement. And we're explaining how we get from that entire angle being 180 into each angle being 90. We can cut it in half. Why can we cut it in half? Because it's an angle bisector. By definition, that's an angle bisector. And by definition, what an angle bisector does is it cuts the angle in half into two equal pieces. So that's a couple different ways to show these explanations. Your homework is going to be trying a few of these. And remember, on each of these problems, you want to back up your statements with explaining why that is true. Why are these things equal? Why can we set up this equation? Why does it add to that particular number? Those kind of things are things that you want to make sure that you can explain and back up why you're saying those things are true.